Morning. I am Raju Upadhyay from CIMAGE College, Patna, Department of IT. Today, I'll be talking about the concept of multi-threading in Java. And along with that, I'll discuss what is a Java thread lifecycle. So first of all, we need to understand what a thread is. So we can say a thread can be defined as a single sequential flow of control within a program. It is a sequence of instructions that is executed to define the unique flow of control. For example, in the system, we are having a CPU, right? Central Processing Unit that performs various different kind of processes simultaneously, such as writing and printing a document, installing a software, displaying the date and time. All these processes are handled by separate thread within the operating system. An application comprises of one or more processes that can be performed simultaneously. Further, every process is broken into a small chunks known as task. Every thread is assigned a unique task to perform independently. For example, let's say we are having a text editor. As a text editor, we can have a Notepad, Notepad++, or maybe Microsoft Word is an application that allow you to perform two different tasks, such as write to a document and print a document simultaneously. So these two different activities are happening simultaneously. That is just possible with the help of the concept of multi-threading. Further, you can implement multi-threading in an application to achieve an efficient performance and utilize the CPU processing capabilities. In order to implement multi-threading, Java provides thread class, and alternatively, Java provides Runnable Interface, right? In order to work with the threads, we need to first identify their life cycle. So before going through the life cycle of a thread, we should understand the basic concept of thread or multi-threading. Let's say a single-threaded application can perform only one task at a time, but there is a big problem in this. A single-threaded application needs to wait for one task to complete before another task can start. As a result, the efficiency of the application is getting hampered. On the other hand, you can apply multi-threading where when there is a requirement to enable an application to perform several tasks simultaneously. As I taken the example of your operating system, or within the operating system, we have the text editor and multiple tasks happen simultaneously. Multi-threading helps to perform multiple tasks simultaneously, which saves our time, as well as it improves the execution speed and efficiency of your application. So every application that has at least one thread, or you can create any more threads if required. So if the application is having minimum 2 threads or more than 2 threads, are called multi-threaded application, right? Now, we can talk about the microprocessor. The microprocessor allocates the memory to process that are executed by an application, and every process occupies its own address space or memory. However, all the threads within a process occupy the same address space because all threads belongs to the same process, right? So within a process, one thread can communicate with other threads. So let's start with the concept of what is called thread lifecycle. It's very important for thread programming. The various states in the thread lifecycle of a threads could be, thread can be in the new state, it can be of runnable state, it can be of not runnable state, it can be terminated or dead state. But thread can be found in only one state at any point in time, right? So first of all, we will talk about when the thread gets the new thread state. So when an instance of a thread is created, right, the thread enters into the new thread state. So like, let's say, if you wanted to create a thread class object, so obviously, as I mentioned, in order to create a thread class, we require a thread class. So how we can create an object of a thread class? Simply, we can write thread, which is the class name, followed by reference variable name equal to new, that is a keyword which is going to create thread dynamically at runtime. We will see everything happening while I'll implement the concept in a program. and that can be initialized with new followed by thread constructor. And within this, we can have a thread name optionally. Even if you don't give a thread name, automatically system will provide a name to a thread, right? And once the thread class object is getting created in the memory, it enters into the new state, right? And once it is getting entered into the new state, it is still there in the new state in the memory, and that thread can be called as empty object of a thread class, and they don't have any kind of system resources such as memory. Clear? You can activate that newly created thread just by writing the start method. So how can we do that? We can invoke the start method just by using the thread reference variable. So within a reference variable, if you have created a reference variable of a thread as new thread, so we can write new thread dot start. Once you invoke the start method, your thread will become in runnable state. So the runnable thread state is a state where thread is not running, but is there. It is there in a queue of microprocessor, and they keep on waiting for their turn to come. Whenever their turn will come, automatically it will start running. So just now I have discussed, whenever you create an object of a thread, it is in new state or born state. Now the next state is the runnable state, and how we can go to the runnable state the moment you are going to call a start method of thread of reference. Clear? So as I mentioned, when the start method of a thread is invoked, the thread enters into the runnable state, and the start methods allocates the system resources to the thread at this time, right? Schedule the thread, passes the control of that particular thread into the run method. So run method is a very, very important method. So the functionality of entire thread is written inside the run method. A processor cannot execute more than one thread at a time. As we know, we're having a microprocessor attached to our laptop or PC. And one processor, as we know, one processor can perform only one task at a time. Therefore, the processor maintains a thread queue, right? So when the thread starts, it is in queued for processor time, and it waits for its turn to execute. And as a result, the state of the thread is said to be runnable, and it is not running. The moment processor is giving attention to that waiting thread, that means the threads which are running, which are waiting for their turn to come in the processor queue, it starts running, right? And after running, there is another state of a thread is called not runnable thread state. So what are the situations where we can say thread is in not runnable state? So thread is in the not runnable state if it is sleeping. So thread is put into the sleeping mode by calling a sleep method. So there is one static sleep method of a thread class where we can call that particular method. So sleeping thread continues with its execution after the specified time of sleep has been elapsed. That means within a sleep method, we can write a number, and that number has to be in terms of milliseconds. So if you wanted to make your thread sleep for 1 second, you need to write 1000 as a parameter to that particular static sleep method. Another condition could be your thread could be in a waiting state. A thread can be made to wait for some specified condition that need to be specified or satisfied by calling a wait method. So there is another method called wait, right? And this wait method belongs to the object class. This is the ultimate parent class of Java object hierarchy or class hierarchy. The thread can be issued a notification of the state of the condition by invoking notify or notify all method of the object class. That means if your thread is in waiting state, it will keep on waiting in the waiting state until you call it through the notify or notify all. Another condition could be one thread is being blocked by any another thread. If the blocked by any another IO operations, the thread enters into not runnable state, right? So these are the conditions under which we can say that our thread is in not runnable state. Now the final state could be the dead state, right? A thread enters into the dead state once the statement of run method have been executed, right? That means the task of the thread has been over. That means we have come out from the run method, automatically thread will enter into the dead state. It is assigning a null value to the thread object also changes the state of the thread object to dead. And if you wanted to verify whether the thread is still alive or not, so there is a one method called isAlive. So isAlive method is of thread class, which is used to determine whether the thread is alive or not. You cannot restart a dead thread once it is dead. In addition, the thread can be killed by stopping their execution with the help of the stop method, right? So there are three ways to make your thread dead. One is once your run method is over, it is going to be in dead. Once you assign the null value to the thread object, it is going to be dead. Or forcefully you are going to call stop method of a application, it is going to be dead. Or even if you close the application itself by clicking on the cross button, your thread will enter into the dead state, right? So now, in order to create a thread, obviously we have to write the user-defined class. And that user-defined class has to be extended by either thread class, or if it is not possible, so you can implement another interface called Runnable Interface. Now the question comes in, when do I use a thread class as a parent class and when we can use Runnable Interface? Let's say, take a situation if you wanted to create your application. For the application, you have created a class, and that class is already inherited by some urgent or important class. Clear? So as we know in Java, one class maximum can have only one parent class. So we don't have an opportunity to extend a second class as a thread into the user-defined thread application. For that condition, we have to implement Runnable Interface, which Java has provided to us. So here, as an implementation part, what I'm going to do is, I'm going to take an example of, let's say we have created a one jumbled up word game, where we need to implement a timer in that game. A timer will be used to provide a duration of 60 seconds, within which a player has to find the correct word corresponding to the jumbled up word, right? So once the player is going to be complete their work, that means they are going to find the right word within the 60 seconds, so that player can be considered as winner, otherwise player can be considered as loser. So here I'm not going to have, we are not going to have for entire implementation, but I'll be creating a one thread by which your application will be started, and within application, your timer will be started. That means within a timer, you will be having a 60 second, it will keep on decreasing till 0 seconds. The moment it reaches to 0 second, it will give a message called timer, right? So that we are going to understand. So in order to implement it, I'm going to switch over my screen into the implementation mode. So I'm going to share my screen to you, where I can write a program, and we will see how the applications are going to work. And along with writing a program, I'll keep on explaining each and every statement of the program. And more importantly, here I'm going to make use of JFrame class. So we are going to create a one frame, and through the frame, everything's are going to happen. Hope my screen is visible to all. Right. Here, I'll be writing a program from the beginning. So I'll be writing out here import. We have to import set of classes. I'll write import java.awt, and within that, I'm going to make use of color class. Right. I'm going to make a colorful screen. Then I wanted to change the font as well. So I'll be writing import followed by java.awt dot font class. Now, I have to make use of JFrame class. So here I'm going to make use of another package called JavaX. Import JavaX dot swing, because the component that frame is JFrame is a component of the swing package only. So I'll select the swing and I'll take all classes from there. Now I'll start my class. So as usual, we'll write public class followed. Let's say it's a countdown timer. So write user-friendly name, countdown timer. This is the name of a class which I'm going to give. And obviously, it has to extend from thread class, because I have to implement the concept of thread in this particular class. Right. And then my class starts here. And within a class, I'm going to have one text field where I'm going to display the timer message. So for that, we are having a class called JTextField. JTextField followed by the reference variable is, let's say, TF, text field. Then I'm going to create a one label. For the label, I'm going to create a J label. And their reference variable is, let's say, L. Apart from that, I'm going to have a frame, because as I said, I'll be implementing the concept of frame. So this is the J frame followed by, let's say, F. Right. So these are the important control which I need to use in the program of multithreading. Now, as we know, inside the thread class, we are having a two important method that is called start method as well as a run method. So here, I'll be making use of run method here. So in order to override the run method, I'll write public followed by, obviously run method does not return anything. So I'll be writing a run public void run. And here you have to write the functionality of entire thread. So the functionality of entire thread I'll put inside another method called buildGUI, right? So buildGUI means that will create, that is responsible to create a frame, and it is going to put everything within the frame like text field and label control. So for that, I have created another method called buildGUI. I'm going to create another method called buildGUI, which I'm going to call it from here. So obviously that buildGUI need to be written out here. Right. So I'll be writing, let's say here I'm going to write the template for buildGUI, and I'll be quoting it a little later. And after that, I'll be having one more method called display. Right. So this display method is responsible for displaying frame on the screen. Clear. Rather, display method will be responsible for displaying the timer on the frame, within the frame. So this is also not going to return any value. So I'll be writing a void display. Right. And within this, we'll be writing a code. And first of all, I will keep on writing the templates only. And as we know, everything is getting called from the main method only. So I'll be writing public static void main. Within this, we'll write as usual string array as a parameter, right? And within this, we have to create an instance of our class. So for the timing, so far what I've created a class extended from the thread class. Within this, I've created a 3 component for a frame that is called JTextField, JLabel, JFrame. And as usual, we have overridden a thread class method called run, which is having a complete functionality of thread to be performed. And in turn, that run is going to be called buildGUI. And within the buildGUI, we're going to write the user interface content, as well as display method is going to display the content of that. And everything's are going to be triggered. Everything's are going to be triggered through the main method only. So let us code the main method, right? So here, what I'll do is I'll be creating an object of countdown timer. So this is the class which we have written earlier, countdown timer. Let's say for that we are going to create a reference variable obj equal to new countdown timer, right? And once it is executed, that means whenever you create an object of countdown timer class, and since the countdown timer class is extended from the thread class, you can notice out here. That means you have started with the thread, right? And now thread, the new object of the thread is got created here. And here we have to execute it. So here I'll be writing obj dot. In order to start a thread, as already we have mentioned, this is the start method. Obviously, this start method will take us to where? It is going to take us to run method. And in turn, run method is going to take us into a build GUI method, right? So here I'm going to code build GUI. So let us complete this build GUI. We have to make it as public void. It is not going to return any value, so that is void. And within this, we have to write everything. Right, here what I'll be doing is, first of all, I'll be initializing the frame object. Right, so my frame object is your f. Right, here we have declared the reference variable as f. So here I'll be writing f equal to new, and within this we'll call a method called jframe. We'll create an object of jframe class. And if you want, you can have a title of this particular jframe here itself. So within the double quotes, we can write their title. Obviously, this is a kind of a countdown timer. So I'll write countdown timer. So this is going to be the title of your frame which we are going to create. That means as a title bar, this countdown timer will be displayed to us, right? Now, we have to create a panel. That means within a frame, everything has to be kept as a part of a panel. So I'll be creating a JPanel object. So here I'll write JPanel followed by a reference variable of the JPanel. Let's say I have created a reference variable of the JPanel as P, and that has to be initialized. New JPanel, right? And no need to pass any parameter out here. Default panel will be initial. So panel is a kind of a container. This is going to contain every control which we have created. Like this panel is going to create the text field as well as label control. So now our turn to initialize text field as well as label. Once the panel got created, then we have to initialize with the text field. So I'll be writing tf equal to new j text field. And then we have to initialize the size of that particular text field, right? So here I'll be writing, I want the width of the text field has to be 25. So I'll be writing like this. Likewise, we need to initialize with the label control. So I'll be writing L equal to new followed by j label. And for the timing, nothing will be there on the j label. So I'll be writing j label. And within this, I'll initialize with empty. So simply I'll write pair of double quotes. So initialization has happened for frame, panel, text field, label. Now next thing is that I need to add these kind of things inside our frame, right? So what we can do is we can and one more thing, I wanted that this text field should be disabled. That means, since as we know, text field is allowed to the user for doing the data entry, right? For entry anything. But this text field I have used only for displaying the content. So what I'll be doing is I'll be writing tf dot set enabled false. Set enable, and within this we'll be writing a false. Right. And after that, obviously the false has to be f should be small only in Java. So this got disabled, and after that we have to set the font. So already we have imported the font class. So the font class reference variable has to be created. F equal to new font, and this font has to have a 3 parameter, right? The first parameter is the name of the font. Second parameter is the type of the font. So let's say my font is Verdana, and here is a second parameter. We can write 0, 1, or 2. 0 for normal, 1 for bold. I want to get the things bold, so I'll be writing 1, comma, and followed by the size of that font. So I'll be writing out here, let's say 28. So it's going to produce a average kind of font size, and then this has to be applied on TextField. So I'll be writing tf dot set font, right, in order to set the font. The font which we have initialized is there in the F. So font got initialized out here, and then we have to set the background. Clear? We have to set the background of the text. So by default, background of the text will be white. So I wanted to make it as black, right? So what I can do is I can write for tf dot set background, right? Set background. Here I'll write color dot black. So it is of black color. And then we have to set the panel background as blue. So obviously for the panel, I have taken a reference variable called p. So I'll write p dot set background and background. And here I'll be writing color dot blue. So our panel background is going to be blue in color, right? And after that, we have to keep on adding all these control inside a panel, right? So first of all, panel has to be the part of frame. So I'll be writing fr dot add, because in order to add any component, we have a method called add. So first of all, I'm going to add panel into the frame. And once the panel got added into the frame, so we have to keep on adding items onto the panel. So I'll write p dot add, and within this, I'll be writing, first of all, I'll be adding the text field. Then I'll be adding a label control that is having a reference variable called L. And then we have to make every content visible on the screen. By default, the frame which we have created, by default, it will be there in the memory, but it is not visible to the user. In order to make visible to the user, this frame has to have the set visibility property. So we have to write set visible. So through the set visible, right, through the set visible method, it is going to be visible. So we have to make it as true. Because by default, set visibility property is false. So we have to make it as true. Now, I want to set the property for frame. So if any user is going to click on the cross button, automatically the frame should get closed. For that, what we have to do is we have to write fr dot set default close operation. Default close operation. Set default close operation. And within this, we have to write a very important parameter that is called exit on close. So that exit on close is a kind of a constant variable, which is a part of JFrame. So we have to write the complete path. We have to write JFrame dot exit on close, exit underscore on underscore close. So we have to be very careful while writing this statement. Once we have done it, then we have to set the frame size. That means we have to define the dimension of the frame which I wanted to get it on the screen. So we'll be writing fr dot, fr referring to the frame, then set size. So this is going to set the dimension. So we'll be writing a set size. And then we have to specify their width and height. So I'm mentioning out here as a width is 500 pixel and height as a height 200 pixel, right? And then I don't want that our frame should be resizable. So we can make the frame unresizable. So we have to write set resizable property to false. That means if anybody wants to change the frame dimension, they cannot. And then from here, do you remember we have written one method called display? So here from here, I'll call a display method, which is going to run the timer. So from here, I'm going to call a display method. Now everything has been done. Now we have to do the coding of display, because this display is going to make entire show operational. Now we are going to code display method, which is going to display the countdown ticker on a text field. Obviously, it is going to be displayed for 60 times, starting from the 62nd till 0th second. So in order to do the repetitive task, we have to make use of for loop. So let us implement using the for loop. So this is the for, here int I equal to 0. This is the initialization of the for loop. And then not exactly with the 0, it has to start with the 60. So I'll be writing 60. Then here I'll be writing as a condition I less than I greater than equal to 0. And then I has to be incremented by 1. So we'll write I plus plus. As a body of the loop, we have to make use of the slip method of thread class. And as we know, slip method is a static method and it always written inside the try block. So let's start with the try. So within a try, we'll be writing a slip method. And slip method of a thread class, which is the static method. So directly by using a class name dot slip method, we can write it here. So here I'll be writing thread dot slip, and within this we'll be writing number of milliseconds for which the thread is going to sleep. Obviously, for 1 second, there is a 1000 millisecond. So we'll be writing a 1000 over here, right? And after that, what we have to do, obviously the initial value of I is 60. So that 60 we have to print inside the text box. For that, obviously 60 is a number, and as we know, text box displays only the text value. So we need to convert it back into the string. For that, I'm going to have one string object, let's say s equal to, we have to convert integer into string. So we'll write integer dot to string, and within this the value of I. So I'll be writing I out here. Now we have to ultimately the value of this s, which is the converted part of 60 into the text, into the string, has to be displayed in the text field. So for the text field, the reference variable is the df dot set text, right? And there we have to set the pattern. So as a pattern, I have started with double quotes, right? And as a double quotes, I'll be writing here, within this, we'll writing plus the value of s, again plus, right? Then again, I'll make few space out here, and here I'll write seconds to go, and then this line is going to be terminated now. So just you notice out here the kind of pattern which we have made. So it will display in the text field the value of s, that is 60, and then after that I have mentioned out here one space, then seconds to go and triple dot, right? Now, the job of try is done. So obviously for the try, there must be at least one catch as with. So we'll write catch, and within this, we'll write exception followed by reference variable E, right? And I'll write opening and closing curly braces. And within this, if any exception comes, so we'll display their value as it is. For that, I'll write system dot out dot println, right? And then the value of E, which is the exception value, I'm going to print here. Now the job of catch is also over. So this is the end of the catch. This is the end of the for loop. Now, the moment we will come out from the for loop, we have to display a message in the dialog box called timeout. For that, we are having a class called OptionField. So here we'll write OptionField. We'll take it here. Dot. It has a method called show message dialog. So we'll write show message dialog. And within this, we'll be writing a frame reference variable called fr, not fr exactly, this is the f only, comma, then we'll have the message. That means show message dialog has two parameters minimum. One is the reference of the object where you want to display the message, and the second parameter has to be the message which you want to display, right? So here I'll be writing time up, and then if you want, you can write it like this, and then this is going to be terminated out. Now, we have to clean our text field. So obviously text field is referred by tf dot set text, and within this we have to clean it. We have to make it blank. So I have written pair of quotes, double quotes, and then we have to again disable our text field. So we say tf dot set enabled, right? Set enabled. So I have issues with my keyboard. So set enable, set is the one word, enable is the second word, so it should start with a capital E, right? And then here I'll write false. So this code is ready for the display method, right? Now we need to save this file. So obviously I'm going to save it. And obviously my file name is countdown timer, and it has been saved in the D drive root. So what I'll do is I'll go and I'll compile it. So in order to compile, I'll go for command prompt, and here I'll say Java C countdown timer dot Java. Oh, it's having error. So let us see the reason behind the error. So it is having an error with the reference variable f. Let us see starting from the line number 26. So what I'll do is, let me verify whether my screen is visible or not. Command from the screen. Oh, command from the screen. Oh, my screen is not visible, so let me share my screen to everyone. So I'm going to start a new share. And this is the screen which I wanted to share. So now my screen is visible to everyone. So just now I compiled my program and my program gave error, right? So what I'll do is I'll go back to my program and we'll find where is the error. So error starts from here. So reference variable f is for the JFrame. And yes, we did a mistake here. I have created another reference variable called f for the font class. So let it be as f1. Clear, and set font is f1. Fine. Now it must have resolved my error. So again, I'll go back to my window, right? And I'll recompile it again. by writing Java C down timer dot Java. Yes, there is no error now. There was only a reference error because you cannot have two reference variable having the same name in the same scope, right? So that was the basic issues. Now we will run this program. So obviously, in order to run it, we'll write Java followed by count down timer. Right. The moment I click on this, just all of you can notice here I'm getting a message, but the screen is not properly visible. So what I can do is we will do some sort of correction in a program. Right. The reason behind, let us visualize here. Obviously, we are displaying it in this particular location. So our text field is of 25 character. So I'm going to make it as the width of the text field as 30, and my width of my frame is going to be 600 by 200, and then because the data is not displayed properly, and here I'm going to have few more spaces, so it should come in the focus. Now I'm going to save it and I'm going to compile it again. So that you have to take care if the output doesn't come properly. Again, it has some issues. I'm going to increase the width of my frame. It's a 600 by 300. And again, I compile it. See, the last few sections is displayed here. So still, I need to set the frame properly. So what I'll be doing is, you need to do the little adjustment while getting the output on the screen, right? So again, I'm going to increase it like this. So it should come in our focus. Yeah, now it has come into the focus. And one more mistake has happened there. We need to decrease by 1. So your counter should go in the backward direction, right? So let us, this is the final call. We can run it now. Definitely it's going to work fine. See, this way your timer has been created and it's going in a reverse direction. And obviously it is going second by second into the backward direction. The moment it will reach to 0, automatically you'll get the message time's up. So far, if you have not liked my video, please do like. If you are a new visitor to this particular channel, please click on subscribe and notify bell. You click on the notify bell So you can get whatever video I'll create and upload it, you'll be getting the post to you very quickly. As well as if you have any sort of doubts, question related to my video, right? If you have any sort of queries, questions, you must write into the comment section. I'll go through your question. I'll reply back to you very shortly. Now see, once it is getting covered up, it has finished their work, automatically we are getting a dialog box, clear, and that dialog box has a content that is called timer, right? So this was the overall how the thread multi-threading has happened, right? And within this, what is the thread life cycle? So we learned about what is thread, what is a thread life cycle, how to implement the concept of thread using a timer class, right? Hope you must have liked this particular video. Don't forget to click on the like button, and I'll be coming with the next video with the new content. Thank you very much for watching this video.